Hello and welcome to this short introduction to carbon capture. My name is Stephen and I'm going to tell you a little bit about the history of industrial fossil fuel use and how this has contributed to climate change. Carbon capture is a technology that allows us to stop carbon dioxide gas, CO2, produced by combusting fuels in industry from entering the atmosphere. We're going to look at how this technology can make our power station carbon negative. First, we must take a step back in time nearly 300 years. The Industrial Revolution began in the mid-1700s in Europe and a little later in the United States. The world of manufacturing and industrial processes boomed with the invention and refinement of automated machines such as the steam engine and the spinning jenny. As the industrialization of the economy accelerated, the need for fuel to power this revolution increased dramatically, with the need for coal at the forefront. It's probably worth going back even further in time at this point, 300 million years, to take a look at where this coal comes from. The Carboniferous period of the Earth's history was some 300 million years ago. The planet was home to dense forests of very tall trees up to 50 metres high, but they had very small roots. The trees were constantly toppling down onto the swampy forest floor. Now the wood-eating bacteria, microbes and fungi that exist now and live off fallen trees had not yet evolved, so the trees were left to sink into the ground as more and more trees fell on top of them over millions and millions of years, compacting them into coal. The rush to find coal to use as the fuel to power the Industrial Revolution resulted in more and more coal mines being opened all over the planet. As coal near the surface was used up, the mines became deeper and deeper. The industry continues to extract ever more coal, and although we no longer mine significant amounts of coal in the UK, globally coal production is still yet to peak. As we can see from this graph, the growth of industries around the world has resulted in a steep rise in CO2 emissions over the last 50 years. This rise is tracked by the amount of CO2 found in the atmosphere. For millions of years, there had been a balance in the carbon cycle between CO2 emitted and absorbed. Cataclysmic natural incidents affected this balance, such as volcanic eruptions, but over time the balance was always redrawn. With the growth of the Industrial Revolution, the use of fossil fuels that fed this expansion upset that balance. By combusting fossil fuels, carbon dioxide is released into the atmosphere. We call this a greenhouse gas. Other greenhouse gases present in the atmosphere include methane, nitrous oxide, and water vapour. These all play a vital role in keeping the planet warm enough to support life. Let's take a look at how they do this. The sun's radiation travels towards the Earth. About half is reflected or absorbed by clouds in the atmosphere. The rest of this reaches the Earth where it is absorbed by the oceans and land. The Earth also releases heat back towards space. Some of this heat passes directly through the atmosphere, but most of it is captured and retained by greenhouse gases. The effects of a rising global temperature can be seen in the retreat of glaciers and polar ice melting. As a result of this, sea levels are rising. Rainfall patterns are also changing, producing floods or droughts. There will be profound consequences for billions of people all over the planet as a result of these atmospheric changes. We can break down the various human activities that go toward the release of excess carbon dioxide. As we can see from this illustration, there are many different areas of human activity that contribute to creating excess CO2 emissions. At this stage, it's probably worth having a quick look at how a power station works to produce electricity. A thermal power station like Drax uses heat through the combustion of fuel, coal or biomass, etc., to boil water to make steam. This steam turns turbine sets which turn a magnet inside a copper-filled housing. This creates the electricity. There are CO2 emissions through the combustion of fuels. Drax traditionally used coal but now uses biomass. There's an important difference in the relationship that these fuels have to the carbon cycle. If we can stop the excess CO2 from entering the atmosphere, we can make a significant impact on the current imbalance of the carbon cycle. But how can we do this at our power station? We're currently capturing small amounts of carbon dioxide at Drax before it enters the atmosphere by using a specially devised solution that absorbs the CO2. The CO2 can then be extracted and either stored or used as a product commercially. We are working with partner organisations to enable us and other clean tech companies to develop a better understanding of the potential for using CO2 from our biomass flue gases. This could enable new technologies to be developed which make a positive contribution towards the UK meeting its zero carbon targets. We are already trailing 2 separate pilots through partnerships with Mitsubishi and BECCS. Here's an illustration showing the current setup at Drax involving BECCS. When fuel is combusted to create heat, there is a release of gases. These gases are injected into devices called absorbers. It is here where BECCS' solvent can collect the CO2. Heat is then used to separate the CO2 from the solvent, allowing it to be captured and stored. The solvent can then be used again. If we capture the carbon and use it commercially as a product, there are lots of ways to put that carbon dioxide to use. In fizzy drinks, in plastics, cement, decaffeinating coffee, in fire extinguishers, and also fish food. Storing the CO2 rather than using it is the ultimate goal, and scientists and engineers have found the ideal place to put it. After years of extracting oil and gas from under the North Sea, there are lots of empty spaces and pipelines still in place that can be used to store the CO2 in. The UK has set a goal to become net carbon neutral by 2050. To achieve this, some industries will have to go further to help those that cannot practically or financially achieve it. At Drax, we can use carbon capture technology to help achieve this goal by going a step further than our electricity production being just carbon neutral. We can do this by using biomass as our fuel. Biomass is the waste wood from the timber industry. The CO2 released when this fuel is combusted is known as biogenic. This means that it is already carbon neutral due to the CO2 in the atmosphere that is absorbed by these trees as they are grown in managed forests. By storing the CO2 from this process rather than just capturing it, we will then have a carbon negative power station. By joining in partnership with nearby industries, clusters of businesses can be created which will contribute towards a balanced zero carbon region. The Humber is ideally placed to play a leading role. As a region of high industrial activity, it has the most concentrated carbon output in the UK. Investing in carbon capture technology not only ensures hitting zero carbon targets, it provides new employment opportunities and places the region in the forefront of international efforts to limit the effects of climate change. Here's an illustration of what this might look like. It's unlikely there will be any let-up in the demand for electricity, so it is vital that energy comes from renewable, carbon-negative sources that also contribute to a wider regional response to climate change. Okay, I've got some questions for you. There's 5 in total. Question number 1, in what century did the Industrial Revolution begin? Question 2, can you name 3 greenhouse gases? And the third question, what are the 2 companies that Drax are currently working with on their carbon capturing project? Question 4, where are scientists ultimately hoping to put CO2 to store it? And question 5, what does BECCS, BECCS stand for? Okay, I've got some answers for you. So the Industrial Revolution, it began in the 18th century. That's question 1. The answer for question 2, the greenhouse gases, you could have had carbon dioxide, methane, water vapour or nitrous oxide. The companies that Drax are working with currently are BECCS and Mitsubishi, and the place where we're going to be storing that CO2 ultimately is under the North Sea. And BECCS, that stands for Bioenergy Carbon Capture. storage. Well, that's it from me. Thank you for watching, and do keep an eye open for next week's presentation. Bye.